So welcome back, warm welcome also from my side. My name is Michael Zangl. I work at Austria and I'm also part of the DATEX II PSA Technical Management Group. So thanks to all the speakers we had today, very good inputs, also some new inputs. Also for me being part in the DATEX II PSA, also some new and novel stuff we've heard today, very interesting. Yes, about DATEX II appears as a powerful information model today with its several core parts. We have heard from part of these for the traffic and traveler information exchange on the road. But as the progress in the field of ITS does not stop, neither does DATEX II, as it is continuously developing and expanding in both the ITS area for urban and the ITS area on higher road networks. So for this session, I would like to introduce you to my colleague Paal Aaserud, DATEX II PSA Technical Management Group member and a longtime DATEX II expert for now already about 10 years. Paal is a consultant, actually CEO of the Vianova network in Norway, and is already involved in developments. I think he was already involved in 2012 when really the DATEX II implementation kicked off in Norway. And nowadays he's the project manager for the new traffic management center system built in Norway, where DATEX II will be at its heart. So Paal is going to give you an introductory that focuses on the appliance of the core parts of the information model in operational use. Following a short walkthrough of the new parts of DATEX II, and finally he will emphasize on real example cases on how the entire DMC systems are built using DATEX II as a strategic choice. So, and again, as you will have the opportunity to ask questions via the Q&A section of the tool, either it will be answered immediately, or I will forward the questions at the end of Paal's presentations. So Paal, the stage is yours. Please go forward.
Thank you very much, Michael. I will try and focus today on the functional aspects of how we apply and use DATEX. And of course, as Bart says, the data is the most important and probably the most interesting topic for a lot of people. So what I've prepared for you today is a short walkthrough of the core parts of the DATEX standard and how we use them. So you can see some real data visualizing the standard, so to speak. And for the next session, of course, we will go in more technical detail to have a look at how this data is actually transferred and represented. I'll do a quick overview. There will be probably a little bit overlap between what Bart said and what I'm going to say, but I hope you can bear with me. I think I've tried I'm trying to communicate this in a very common terms. Not, I emphasize not to use technical terms at all. So DATEX is the electronic language that is in use in Europe today for exchange of traffic information with related traffic data. DATEX was initially developed because of the need for data exchange, hence DATEX, the abbreviation, of traffic-related information between traffic centers and road operators. The development started a long time before I was involved in DATEX, and was initiated as early as back in the 90s. And then it was named DATEX Roman number 1. And from the millennium shift, it became DATEX II and also progressed towards European standardization. DATEX II version 3.x is the latest version. And this standard is now bound to the European transport policy in line with the ITS action plan and the directive that follows the action plan. and that is issued by the European Commission. So I'll very briefly summarize all the parts of the standard. So DATEX II is now a CEN standard. That means it's standardized by the European Committee for Standardization. And EN, as the short letters at the end of each part, represent that it is a European standard. And if there is a TS behind, it's a technical specification. These now total of planned 11 parts. Starts with the more core parts at the top here. I'll try and show my, yeah. So you see the part 1 is really only the description of the content and the framework itself. And part 2, as Bart also addressed, is the location referencing, where there is broad different standards of referencing you can use to locate your data and say which location they are representing on. And there is the situation publication, probably the most used one, which addresses traffic situations. And usually everyone uses this one to publish traffic information. And there is a part 4 VMS publication, which addresses variable message signs. You see that I've also written that there is a version 3.0, which was the first 3 parts there. They are already standardized. And we also now, as Bart also mentioned, we are working towards a version 3.1. And there will also be a version 3.2. So starting from version 3, there is we have the more ability to produce minor versions of the standard without breaking the standardization itself. So VMS publication is the variable message signs, different variable signs that can have different positions. The part 5 is the measured and elaborated data publication. That is probably, that relates to the question about road weather data. I will also show a sample of how road weather data looks like published with this part of the standard. The parking publication has gone a few rounds, but there exists one version today, and there will be work towards a new version with the alignment of the parking alliance, which we have concluded is more suitable because they own the domain. So the parking publication will align against their work, but still be published as a part 6 here in the standard. The part 7 is the common data elements. That's basically everything that can be reused in the other parts. So probably Ian and Jonas will go into a little bit more detail than on how that will look. The last 4 parts here are the new ones. I will briefly discuss them on a slide at the end. But you can say that Bart mentioned all this. The traffic management publication is the part 8. The traffic signal management publication is the part 9. The energy infrastructure is the part 10, and management for electronic traffic regulations, meter, is the part 11. So I'll focus on a little bit on those first parts here, including from part 1 to part 7. So what is the DATEX II model really? The DATEX II consists of an information model, which in its simplest term is actually the information content you want to transfer between 2 or more parties. It represents the formal representation of information that cannot be misunderstood. That's why DATEX II uses a formal modeling language, UML, that will prevent different parties from misunderstanding the information content itself. The different parts in the DATEX II standard make up the different information packages that a payload of information can consist of. So when we are referring to payload, we mean the information content that you want to transfer between two parties. DATEX II is now in the new version can be extended further, and there is an own process for making extensions that actually can be reliable for future parts of the standard if you comply to the process. I think also in the technical session after mine, you will be introduced to the levels of extensions you can make. The DATEX information contents, or merely said, what you want to publish, are specified separately from how you want to technically transfer it, as we refer to as the exchange protocols. And that's allowing for a very flexible use of the content, and we can use it defined with many exchange protocols, and version 3.x will align against one of such standards from the ISO TC 204, the Technical Committee 204. So ISO is the short abbreviation for the International Standard Organizations. So here we have an information content that is standardized in the EU, and we are using an international standard for exchanging it between two parties the technical way. That's the message from this slide. As Bart also mentioned, there has been formalized that we have the need to establish national access points, and the member states are encouraged to do so, and they should do that in an EU-wide interoperable way, so that so they are easy to find, and they will be more or less generalized, so they are easy to search within. An app can take various forms. It could be a database, data warehouse, marketplace, repository, register, web portal, whatever. But the main thing about the NAP is that you should be provided with the data that is available in that country. The national access points is adapted under the directive. There is a link here, so you can go and read when you get a copy of the presentation. You can click on this link, and many of the priority areas that are described in this directive are covered by DATEX. Those priority areas also a link here to the DATEX2.eu site, where you can read a little bit more about that. So I'll start by trying visualize how this standard is appears. So you will have one kind of a producer that registers incidents or events, like traffic accidents, for instance, and you will have a consumer that wants to use those data. And between here, we need a standardization, and we need a formal representation of that information, so that everyone will be able to use it in the same way. So the first part refers to the standardization number 16157 in SEM, part 1, which describes the model and the context and the framework itself, which the other parts align to. There is a common part for location referencing, and there is a common part for data structures, which can be reused by the other parts. Because an incident is nothing worth if we don't have a location. You need to know where it is. So, and the next 4 parts, part 3, 4, 5, and 6, are the most mature ones. They have been in the game for quite some time. And what I'm going to do is I'm going to focus on showing you some of the details representing data from these kind of publications. And then there are the new parts, extending more into the urban and ITS area. And this is what you could call the payload. This is what you can send of information content from a producer or one party to another, a consumer. And that's why we call it payload. And it can be technically transferred using the ISO standards that are mentioned here. So this is the whole, let's say, ecosystem for publishing traffic information, also extending into the urban area. There are some stakeholders. I mentioned just a few of them because I will relate to them in the following slides. The road operator, which is responsible for handling incidents. That could typically be a national road operator. And this operator will have a collaboration with the emergency services and will publish relevant traffic information according to how the incident will run through. The service provider will typically use data from a DATEX endpoint and make domain-specific tailored services that are more prepared for an end user. The end user is you and me and everyone driving a car, which use these services to orient ourselves in the traffic, so to speak. So you'll probably have seen a lot of websites and integrated map solutions in cars, handheld devices, smartphones, pads, everything. There are a lot of apps today you can download, but actually you can trace back to DATEX as a source. So then I'm going to start a little bit on showing you some real samples. This is the official traffic information website from the NPRA in Norway, the National Public Road Administration in Norway. And this data that you see in the map here is based on part 3, the situation part 3. And those are referred in slide 6, as I mentioned earlier, where all of the parts are listed. This map shows the traffic situation, and this situation is registered by the road operator. So in this case, the road operator has registered some roadworks and some road closures, and they are published on DATEX. And this client again reads the DATEX data and decodes them and show it on a map. So you can see here that some of the symbols are gray and some are colored. So the gray ones are planned, so they are future events. And the colored ones are the one in action as we speak. When you click on one of them, like let's say the roadwork, you would see typically what kind of information you can get out from a registered roadwork in this case. And you can see that it's valid from and to. We just present very few details from the information here. This is an end user application. And there are some generated text from the other DATEX elements that presents this in a more textually readable way. Behind here, the whole DATEX model has been processed to view this information. This one shows another example. This is an internal client at the Traffic Management Center, the TMC. And here we demonstrate that we actually read off data both from Norway and from the Swedish DATEX node. And you see that this appears quite seamless because you don't really see those two DATEX nodes in operation. What you see is traffic information in the whole country for Norway and Sweden. This one shows the VMS publication, the part 4. As you can see here, there are some VMS signs around the urban area of Oslo. What we do here is we only, for the moment, show the full graphical signs. And here, this is in the, yeah, you see at least the English translation there. So this is roadworks ahead, 7 kilometers. And there is signals in operations, which means you have reduced capacity in the traffic infrastructure. So you have to drive on one lane, for instance. The other example is that we also use those signs to publish travel times. The travel times are actually read from the DATEX node. So the travel information systems that we have, which calculate travel times from A to B, delivers travel information to the DATEX node. And the VMS subsystem then reads off the DATEX node because it reads the travel times. It publishes the travel times onto the sign, and then it returns the bitmap for the travel for the message on the sign, so we can see it in the map. So this is one example of how we have used the DATEX standard as I mean, the DATEX standard is flowing through every part of these systems, and we haven't translated it into something else. This one shows still, now we are jumping over to the RoadData or the measure data. There is an elaborated section and there is a measure data section. So the measure data is more covering observations, so observations you read off as in time now, and the elaborated data is more calculated data that you can, for instance, create new information based on measure data. This one shows the travel times in the urban area of Oslo, and you can see that there are different segments. There are not so much traffic these days, so I tried to find an example with more colors, but both in this morning and last evening there were not so much rush hour. So in this case, you will see you can highlight one of the measured segments, and you can get some information here. It says no delay because it's green, and the expected travel time here is 5 minutes. So and we have this built for all the major cities in Norway, but not for a large portion of corridors. This one shows the road weather data from the road weather information system in Norway. All the green spots here are road weather stations. And this client is using DATEX II and the measure data publication in part 5 to decode and read the measure data that is published for our road weather stations. And you can see here that I've opened one of them, and you can see dew point, air temperature, precipitation intensity, humidity, and so on. And we also have road temperature. We also measure the road surface temperature and wind speed. Some of them have wind speed, and of course then the wind bearing or direction. This is another example from Sweden, from the Swedish Transport Agency. As you can see here, you have the it's similar. You have all the road weather stations here, but here you show the observations directly on the symbol. So this is just another way of representing the same data. But then you see that you can build a lot of different applications with the same data that you get from DATEX. This one is a bit more peculiar because we have a road segment forecast system in Norway. So we also publish those on DATEX. And here you can see the forecasted road conditions for 4 hours ahead. So I'll click on one of the sections that are in purple here, and you see that it states danger, and the road temperature is close to 0. So that would be appropriate, I would say. This forecast model also uses the dew point and some other parameters to calculate whether it will be hazardous on the road segment or not. This is also published on DATEX using the elaborated data publication and the predefined location, predefined publication location for the road segments. This one shows the count of the traffic. So you can see this lane here has 3 lanes in each direction. And you can see the different lanes here, lanes 1, 3, and 5. That's how we number them in the road network in Norway. And 2, 4, 6 is the other side. And then you can see here how many passes of cars and the average speed. So it's for the moment counting of vehicles and the average speed we are using. This gives a good view that if the traffic is building up or if it's loosening up, so to speak, because we have a lot of counting points, so we can use a linear them to see what the prediction would be. We also actually count bicycles now. There was no bicycle out and bicycling when I was taking the snapshot, so then it's gray because there are no registrations. But they have also put up counting of bicycles along the major bicycle corridors into the city center. This is also using, of course, DATEX II as the source. This one, parking publication, we don't have a publication for that in Norway, but Sweden do publish the rest areas. So on DATEX II, so this is an example of how you can publish rest areas and what kind of information you can give to the public. In our national access points, we also publish the 24-hour rest areas for truck parking, but not on DATEX for the moment. But that is something we will consider laying the DATEX strategy for the next period. I think we'll probably wait for the final parking publication before we proceed on this. But this also shows you that here you can rest 24 hours and also some information. Yes, you have access to power. There's no fuel filling plant here. And there's a toilet and there's a shower, for instance. DATEX II Lite was also mentioned by Bart, and it's actually a simplified version of the DATEX II information model, simplifying it using JSON. And an app has been actually developed to demonstrate this simplified version. You can see here that Portugal, Netherlands, Norway, and Sweden are publishing data on this now. And when I was extracting this data last night, there was actually animals on 1 hour in 1 hour mountain passes in Norway, and this was real. So animals were passing on Europe Road 6 over the Saltfjellet, which is one of our mountain passes. You can have a look at this application and download it from the Play Store. I think the Apple App Store as well. And when you get a copy of this presentation, you can just use the barcode here or the QR code, and you can download and install it, and you will see how this could be used in an end user perspective. I think DATEX II Lite will also be mentioned in the next section, so you'll get some more technical details then. There are some service providers, as we call them, which Google is one of the biggest one that's are represented in all countries. They are connected to the DATEX node in Norway, and they are reading off road closed information, as you can see here. And that makes the navigation reroute if you're using the navigation aid in the Google Maps. The travel times here is of course provided by Google itself, and that's one of the reasons we have not published our own travel time system for the whole country, because we are measuring from A to B, but travel information like this are more estimated based on every mobile platform that is moving, so to speak. Another sample of a service provider here. Here we go, which is a public service can be used to acquire traffic information. And they also are connected to the DATEX node in Norway based on situation part 3. And here you also see a road closure, and they also publish roadworks. You can see in the map here. And of course, from my own car, I'll show you of course, this information also ends up in your vehicles. There are different technologies for transferring data. New cars now, they seem to go online on their own, and previously RDS TMC was used transferring codes over the FM band, and they are probably still in use. This one uses information distributed from INRIX. As you can see, you have roadworks, and there is a regulatory event here. I'll show you how that one looks in my car. And then it says traffic information. Yes, this is a regulatory measure. So something is not a normal traffic capacity on this road from Stabekk to the School of VR. You can read it, or you can hit avoid. My navigator will automatically suggest avoid when there is a road closure. So that's why it's so important that, for instance, service providers use the road closed status when the road is actually closed, because roadworks will not get your navigator to reroute automatically. Some very, very brief walkthroughs of the 4 new parts. The traffic management publications, they are set up to managing traffic around events or recurring heavy traffic conditions in an area. And so it's often a pre-programmed set of traffic management actions that will be done in a coherent way. For instance, like when you close a tunnel, like we have a lot of in Norway, then of course different traffic installations needs to have a command in a sequenced order, so you don't create hazardous traffic situations. And then you close bars, you establish wigwags, and you put up messages on the VMS to tell the cars to run another route, for instance. Traffic signal management publication is also focused on the urban environment. They are more or less providing you with the traffic light phase schedules, so you will know when the traffic light will change, which will probably be used in more modern cars and new cars. We are probably in for a big surprise when it comes to how cars will look and appear and behave when it comes to, say, 20 years ahead. The energy infrastructure is a publication aimed to publish charging points, charge type, charge capacity, and is primarily for electromobile vehicles, which we also have a lot of in Norway. So this one we will definitely consider, because we have a lot of different places where people have to go to find the charging points, and maybe we should do some national effort to standardize how we publish the charging points for the whole nation, whole country. The Part 11, the traffic regulation, provides support of the formal digitalization of traffic regulations. It does not encode road traffic laws, as Bard mentioned. It's just the impact of traffic signs. And it's focused on the development is focused on the meters ecosystem, and specifically for the enabling of automated driving. So these parts are quite new, so I don't have any concrete examples yet. Last slide, just to show how we have built, using DATEX as a strategy, how we have built the TMC in Norway now, the Traffic Management Center. And at the heart of this, there is a DATEX node, and we have different subsystems. As Michael mentioned, I'm the project manager for this now. We are actually constructing a new one that will focus more on handling the incident and more or less of the traffic management itself, because that will be part of the incident handling process, hence the kind of symbolization here. We do have a roadwork system where you have to apply you have to apply here to get authorization before you go before you can start the roadwork. And this system is communicating with DATEX internally, so that this TMC system can read off all planned roadworks that will come ahead automatically. So when it's registered here, the TMC system will automatically see the roadwork, and you can just publish it on DATEX. And then there is the road weather information system, which I showed, all the road weather stations. The real-time travel information system, which is measuring A to B, so to speak. So it's in that sense correct, but it of course will be always historic data. The traffic data, counting of vehicles, and then the VMS system controlling the VMS signs. Everything here is a DATEX payload, also internally. And then we also have consumers on the other end. We have an internal system in PRA called Saga, which is a big data platform used for analysis and statistics. And even so, maybe move into the prediction area. We are looking at how to be more proactive in this system, and in combination with Saga, we will probably have a good chance of taking a step further at least. The media, of course, which are publishing audio visualizing messages as well. They can disrupt radio transmission and tell you that there is an accident somewhere. They also publish some of the DATEX data into their own end user services. So that's why it's end user symbol in front here. We also have a map service. So we have converted some of the DATEX data to the OGC, OpenGIS consortium platform. So you can use the DATEX data more in a GIS fashion. And of course, we have different service providers connected, like Google and here. And there is actually around 400 now, and still climbing. And what we are looking at ahead now, which also aligns with the 4 new parts that we were, I was briefly going through on the previous slide, is how we will proceed to construct the ecosystem with connected ITS. So this is a very, very simple possible scenario where you see that this car may detect an accident. It will warn the car behind. It will also tell a service provider that makes it possible for us to get the incident in as an incident detection possibility. And then, of course, when the TMC has handled the incident, every car will get the published information back through one or more service providers. So this is briefly how we have constructed it. Of course, the bottom part of the slide here, we have only tested in a very brief pilot. That is now published as a news item on the DATEX II EU itself.